So yeah, my name is Jason Bock. I am a developer advocate at Quicken Loans, and the talk is Esoteric Programming Languages. A little bit of information about myself. You know, if you have questions during the presentation, feel free to just interject and come off of mute and say, "Hey, Jason, I got a question." Would be more than happy to answer it. You know, and this I'd be much happier to actually be in real life at the event, as I'm sure every speaker would say that. But with these presentations that are virtual, one of the best ways to keep them going is to have that interaction. So if you have any questions, again, just let me know, get my attention, and I'll try to answer them as best as I can. Otherwise, you can send me an email, jason.r.bock@outlook.com, and send it to me later, and I can answer it that way. So there's going to be two demos using a compiler and an interpreter that I've written for these languages, and I'll also explain kind of why I did that and why would you even care about an esoteric programming language, excuse me. So those are the first two. They're called Iron Befunge and Dub Sharp. That's actually for a language called Whenever. And then the third link there is a link to presentations that I've done, including this one, so you can get the slide deck there if you'd like. Okay. Now, I am going to talk about a couple of programming languages before I spend time in the demos on Befunge and Whenever, and one of them has a bad word in it, and I try to keep my talks as family-friendly as I can. Unfortunately, this is a esoteric programming language that a lot of people have heard of, so I kind of walk the fine line here, and I censor it, I blurt it out, but I am going to be referring to it and more on how it actually works. If that still offends you or upsets you, I apologize. Just think of cats, think of kittens. I have two cats, and you're actually three now because we have a kitten as well. So just think of cats and kittens and how cute they are if I'm talking about that, and then just focus on the language itself. So with all that said, the first thing I want to talk a little bit about is just what defines what's esoteric and what does it mean for something to be esoteric. And this is actually kind of important. That when I took a class in college on abnormal psychology, which even though my degrees are in electrical and computer engineering, I still had to take some humanity courses. And I say that like that was a bad thing. But I decided to take this course because a friend of mine who got his degree in psychology said, take this course and take it from this professor. She's really good. And she did a lot of clinical work, and she has, a lot of case histories, which she would never divulge names or anything, but she could use that experience in her classes. And I agree, that was probably one of the best classes I ever took. And what really made an impact is actually in the first day, because after she went through what was going to be taught in the class and everything, she said, so what defines what's abnormal? Is that just different? Is that something that's actually pathologically or clinically definable that people would need treatment for something? And it kind of stuck in my head, who's to, obviously if somebody has a mental condition or impairment that needs help, that's what, you're trying to help those people. But if it's just something that people are being like weird or different or whatever, is that abnormal? It just kind of trying to really get an understanding of what the term means. And when somebody look at this piece of art that I found, I actually looked at the word esoteric, and that was one of them, and that looks pretty esoteric to me. But what does the word actually mean? And of course, one of the best ways to do that is to go to a browser and type in, give me the definition of esoteric. And so that's one that I got. And I think the phrase is difficult to understand, and actually that phrase, and also obscurity, I think really clarify to me what an esoteric programming language is. As you're going to see, these languages, I think, really, how do I want to say this? They really uphold those phrases rather well, or those terms rather well. They're not languages that you would want to use on a day-to-day basis. They are hard, they're difficult, they're weird, they're just bizarre. Like, there's one language that I've seen where it's basically the pixels within an image all mean a certain instruction, and so the JPEG or the GIF is actually encoding a program. Stuff like that. You would never program in such, well, at least I hope you wouldn't, because that would be quite mind-numbing, to say the least. But it's also kind of fun and interesting to see people be creative. And I think that's another point about why I even look at esoteric programming languages. This is a quote that I got from somebody, I believe his name is Mark C. Carroll. He wrote a book called Good Math, and he had a blog for a while. The link in the bottom right there, I don't think his blog exists anymore. Maybe the link still works, but this is something I stumbled on years ago, and he was going through all these what we call pathological programming languages or esoteric programming languages. And this quote stuck in my head, which is not trying to create something that's useful, but something that's bizarre and still compelling. Something that just you look at it and go, wow, that's horrible, and yet really, really interesting. I never would have thought of actually doing something this way. Okay, so that's kind of what we're trying to, and please don't say Perl. Although maybe somebody would say that Perl in and of itself is esoteric code, but I'm sure we've all seen and maybe written ourselves code that is, when you look at it later, you think, what was I thinking when I wrote this code? Okay, we've all had moments like that. But these are languages that in and of themselves are meant to be like that at all times. So that's what you're going to get in this presentation, is a couple languages that illustrate what this looks like. Now, if you get interested in what I'm talking about and you go, I'd really like to just play with these languages a little bit more, or one of the other things I think are really interesting, one of the things I think you can get out of looking at an esoteric programming language is if you want to write an interpreter or a compiler, which is what I did, primarily because, again, my degrees are not in computer science. I don't write compilers on a day-to-day basis. I'm not in the teams that support languages like Rust or Go or C# or anything like that. It's not my day job. So it's also been highly educational to look at these languages and try to figure out how could I write something that would actually execute a piece of code from these languages, which is what I highly encourage people to take a look at. It's been very educational for me. The problem is that if you look at the state of affairs with some of these languages, their documentation or standards is lacking depending upon which language you look at. Some of them have things fairly well defined, and some of them are just basically a couple of bullet points and have at it and see if you can figure it out. Or, it's just an idea. That's really all it is. So it can be somewhat frustrating at times. I would highly recommend that you take a look at this site. The link's on the lower right, and it's called esolangs.org. And it has information about all different kinds of esoteric programming languages. So definitely recommend checking this one out. You'll find a lot of good stuff there. Okay? All right, so first one is called intercal. Okay. At least the languages I'm going to talk about in this presentation. Intercal reminds me a lot about Monty Python. And if you don't know who or what Monty Python is, I feel like I'm showing my age. There are people that are much younger than me that have no idea what a Monty Python is. It's a British comedy.
Okay.
What's that?
I said, I know, it's okay.
That's good. That's good. Sometimes I have to. We were talking about this at work that Office Space came out in 1999 or 2000, something like that. And there are people that I'm now working with that have no idea what I'm referring to if I say like PC load letter or something like that. They were 15 pieces of flair. They have no idea where the joke's coming from. So it's, you get older and that happens. But Monty Python is a comedy troupe. They did movies, they did TV shows in the UK, and they definitely have a very strange, quirky sense of humor that I absolutely enjoy. I find their stuff really, really funny. It's very reflective in this language, that kind of sense of humor. Okay, so if you're wondering, first of all, what does intercal actually stand for? Well, it's an abbreviation for compiler language with no pronounceable acronym. So this is kind of a first thing to introduce you to kind of the silliness you're going to get into with a language like this, okay? Because the acronym actually doesn't relate to what you just saw there. So definitely a lot of silliness, okay? These are the commands that exist within intercal. And to be frank, with this language, I just looked at it, and it's more for humorous sake that I bring it up, because it has that sense of humor. I really don't know all the things about what makes this language actually work, and I don't know if I actually found a compiler or anything for this. But what I love are things like this, like the commands where you're looking at these and you're like, some of these are actually like they're polite or they're not polite, and that actually matters. For example, in the language, it says that you must have 1/3 to 1/5 of your commands be polite. Now do the math on that. Have you ever seen a range that starts from the bigger number to the smaller number? You usually do the other way. And that was another thing that I took a look at one time and went, wait a minute. It's actually going from a higher to lower number, which is quite odd. But apparently, if you are too polite or you're not polite enough, then the program is not supposed to run at all. So, okay. Come from is actually a really interesting, it's almost like the reverse of a go-to. If you ever use a language as go-to where you can just unconditionally jump to some part in your code, apparently come from is you just arbitrarily, if you're from some part of code, you actually somehow get to a part of it. It's like, it's really bizarre. It's really, really strange. I just like this. You have to be polite, but not too polite part of the code. They do have error messages. If you ever saw compiler error messages like these, among other ones that they have, that would make my day. Just it would make it a little bit more entertaining than seeing what are good error messages from compilers, but frankly kind of boring, where they're just trying to help me out. And I'm like, if you just make my life a little bit nicer by, yes, I screwed up, but, tell me something like, E111 is probably the best one. Communist plot detected, compiler is suiciding. I think I would lose it if I was drinking coffee and my compiler just told me that because I did something wrong. So, maybe next time you create error messages, maybe put a little bit more humor into it. This is actually how you do hello world in intercal. Now, again, ask me how this actually works. I have no idea. Apparently, the comma after the do is a way for you to use like a 16 or a 32-bit value, and then you put it, the sub somehow does something with an array. And yeah, I read this and I did what the last line of code says, which I gave up. But apparently, this actually does run as a valid intercal program. Okay. Would you ever want to program in this language? I wouldn't. I would probably, I don't have any hair. Well, maybe my beard. I don't have any hair on the top of my head, and I probably would tear any that were out if I was forced to program in a language like this. Okay, so that's one that's kind of giving you flavor for and a feel for what this world is like. Now, the next one is the one that has technically the bad word in it. Okay, we'll call it brain fudge. If you ever saw the movie, I think it's A Christmas Story, where he says fudge in the movie, but he says, I didn't say that word. So the reason this language I bring up is because it's actually a very terse language. And I personally find it not that hard to reason about. When you first look at code from the language, it can look very much like, what in the world is this? But there's not that many instructions. And if you've ever looked at like Turing machines or Turing tapes, this is very reminiscent to me of a very simplistic machine where you can literally do pretty much anything in a program that you would want to write. Okay. So go back to the next one here. And again, these quotes come from these language creators or people making comments about programming languages like these. And the idea of making a luxury car by gluing parts onto a skateboard, I thought was funny, and I had to look that up, and this is the best interpretation that I could find on the internet. So this is their description of this language. What does this language actually look like? These are the commands. That's it. Okay, so you only have 8 character commands. And you can think of, again, that you have this tape or this kind of infinite memory storage unit. Okay. And when the program starts, you're pointing at the first instruction or the 0th, if you want to look at it that way. Okay. Or I should, not the instruction, but you're pointed at the first memory cell. Okay. If I get a command like an arrow that says then just move to the next memory cell, or I can move back, the plus and the minus just increment and decrement the value at that memory cell. I can output the character, I can input one if I'd want to, and then these jumps will allow you to jump back and forth between your code to do something, depending upon what the value is at the current cell. So to illustrate this, I'm going to show this piece of code, and once we go through this, you'll kind of see, well, if I did this and I started adding on, you'll kind of see where this is going, okay? So again, we start with, we're pointing at the first memory cell, and we start seeing a bunch of add instructions. In fact, there's 8 of them. So we get up to that first bracket, and by that time, the first memory cell is 8. That bracket says, jump to the instruction after the closing matching bracket if what we have is 0, which we don't, we have 8. So we go to the next instruction, it says move to the second memory cell and increment that by 9. There's 9 pluses there. Move back a cell, subtract 1 from it. So now instead of 8 on the first cell, we have 7. And if I gotta make sure I have this right, you jump back if it's non-zero, which it's 7. So we jump back to the leading brace, move to the second cell, add 9, which is now 18. Jump back, subtract to the first cell, which it becomes 6, and we do this iterative thing. And once we finally get that first cell down to 0, what we do is jump to the second cell, and then the period means output the value that's there as an ASCII, okay? Well, kind of what's happening with these cells is we got an 8 there, we got a 9 there, we keep going back and forth. We're basically doing 8 times 9, which is 72, and that's the ASCII character for H. So you see this, and if you now go, well, wait a minute, what I could do is now do the same thing to get an E and an L and an L and an O, and you can print out hello world that way. Okay. So again, nobody would want to code like this on a day-to-day basis, but the language itself, even though it may look very odd at first, it's actually, there's only 8 instructions. There's really not that much to it. And I've seen people take like a higher level language and convert it down to BF and have this really long output, but it would do essentially the same thing, okay? So that's another language. As I mentioned before, there's this one website that you can go to find all different kinds of esoteric programming languages. And like I said, they can be inspirational in a bad way, but they can also be inspirational in a good way in that they can motivate you to either build your own or build something to make these languages actually work. And that's how I got inspired. When I saw these, I went, can't I write something to make these, make this language work? Because as I said in the state of affairs, sometimes it's hard to find things to make these languages actually work. And you just don't find compilers or anything out there that's in a good state to actually run and see if things work as you would expect them to. So it's good fertile ground to play with building interpreters and compilers. So that's what I'm going to actually demonstrate now is an interpreter and a compiler for Befunge and whatever. Okay. So the first language I'm going to talk about is Befunge. And it's somewhat like the BF language I just showed you, except it's not one-dimensional. It's actually, yes.
I just want to clarify. I don't know if I understood you correctly. Are you talking about you built the language or the compiler?
Oh, these languages all existed. I have not created an esoteric programming language myself, like in defining commands or syntax or anything like that. I just created an interpreter, for example, for Befunge and a compiler for whenever. Just that's what I did. But yeah, these languages existed and were created by other people.
Okay. Thank you.
Right. Yep. So this is a two-dimensional language in that it's all character-based and each character has an instruction, but you don't just go back and forth like you did with BF. You can actually move up and down and all over the place. So I'll show an example in a moment. And of course, as developers are, they sometimes go, well, why be limited to 2 dimensions? People have created 3-dimensional versions of Befunge. So you actually will literally like move in and out of the page. And of course, that's hard to actually show because, you know, I'm just on a 2D screen here, but people have created stuff like that. They've created IDEs for this language. I saw somebody do that, which I'm like, wow, that's going above and beyond the Call of Duty, so to speak. But how does this 2D language actually work? Well, the reason why somebody actually created it in the first place was they wanted to create a language that they thought would be difficult, if not impossible, to compile. Okay, and there's one instruction in the language that essentially says change at this place in your 2D space the command to now be this, to be this instruction. And that can be arguably hard to create a compiler to do that, because now you'd have to say, instead of you having these x86 instructions or whatever to represent what this is going to do, now you essentially have to rewrite it. So it's almost trying to drive to making it an interpreter, though I'll show in a little bit some references where people apparently have created compilers for the language. But this is a small subset of some of the instructions that are in the language. This isn't complete, but this will help for the next slide, because I'm going to go through how you actually do a hello world in Befunge. Okay, so you have these arrow instructions. Those are directional. They change which way you're going. If you see a double quote, that's string mode. So that means the next stuff you see after that, you should interpret as a literal string and not as commands. There's a stack. There's a virtual stack in Befunge that you use to push and pop values on, and that's what those commands mean. You can duplicate the stack, and if looks at the value in the stack, pops it, and if it's greater than 0, you go one way. If it's not, you go the other way. You can output values, you can multiply values, and then at ends the program. So if we look at this piece of code for hello world, how would this work? You always start at the top left, okay, and you're assuming that you're going to the right. That's how you first move in Befunge. Now, of course, what we're going to hit is go down and then go to the right. So what you'll see is the stuff at the top, nothing ever gets done with it. It's a kind of a way that you can put a comment in Befunge, is you just create a string there that would never actually be executed or interpreted in any way. Okay, so that's what that's showing up at the top. I move all the way to the right until I hit a down and then to the left. Okay, and then I push a 0 onto the stack. That's basically a null value. Okay, I then go into literal string mode, and I start pushing characters onto the stack, like an exclamation point, D, L, R, all the way up to capital H. I get out of string mode, I move down, and then I duplicate the stack. So now in the stack, there are 2 H's at the top. That horizontal if kicks in, and that will pop one of the H's off, the top H, and it will say, well, that's greater than 0, so I'm going to move to the left, okay, which goes up, and then the comma says, pop the stack and print off the value. So that's why we had to duplicate, because we're going to basically essentially do 2 pops, okay? So we print out an H, we then move to the right, go back down, duplicate, which now is an E, so now we have 2 E's at the top, do the horizontal if, and so you can kind of see now how this is going to eventually print out hello world until it would get to the 0, because that would get to the horizontal if. It would say, oh, you're 0, so I'm going to move to the right. I push a 2 and a 5 onto the stack, multiply that by 10, then print that out. So that's, forget if that's the line feeder or the carriage return, but that's what's going to print out, and then at terminates the program. Okay, so this is how this language kind of works and how it moves around. So as I mentioned before, one of the goals was to have this kind of hard thing about making a compiler for the language. But if you take a look at that site, esolangs.org, they talk about how some people have been able to overcome it, so to speak. But I just wrote an interpreter for it. So that's what I'm going to show as my first demo. Okay. All right. So I'm going to just check here real quick. All right. And I'm going to jump into iron Befunge here. Okay, so both of these are written in C#. That's basically the language I spend most of my time in on a day-to-day basis. But you could write, interpreters or compilers for any of these languages and anything you want. And it's also a good exercise to say, if I'm trying to learn a new language, maybe I use, as an exercise, building an interpreter for a language in this new language. And, that would help you learn that one as well. Okay. But this one just I parse a bunch of text and I put those all as instructions. And so I'm not going to go through in both of these demos every single class and everything, but just to give you a little bit of feel for how I design these and how I put these together. Essentially, I have all these instruction handlers. So you can see here that I have a class that handles all the directional instructions. There's math instructions, number instructions, and so on. Okay. If I take a look at the directional instruction handler, you can see here the ones that I mentioned before. There's also one that does random and one that does trampoline, and these all just will change the direction. Okay. So in my interpreter, I have a way to say I can support these instructions. So if you run into these when you're going through the code, I can handle it. And then on my onHandle method, I will just say, well, looking at this context, which I'll explain in a moment, what's the current value? So if it's a right, all I'm going to do is tell it that now your direction is going to the right or left. The random instruction would actually just use a randomizer and say, I'm going to randomly change what direction you're going in. Okay. And that's all it does. Now this execution context, this is passed into every instructional handler because they may all do different things. For example, if I go look at the math instructions where I'm going to do things like handle, add, and subtract, and so on, when I get down to onHandle here, when I do an add instruction, I'm actually going to do something like, I actually get to, yeah, all these should do the same thing. If I do an addition, I'm just going to pop the two values on the stack and then push the addition of those two values. And that's it. Okay. Now notice here in the onHandle, I have this method called ensure stack. One of the things that the Befunge language says is if you run into an instruction and your stack doesn't have enough values to handle it, to provide to the instruction itself, then just put a bunch of zeros on the stack until you have enough. And so that's what that ensure stack does. I need at least two values for all these math instructions, and they basically just push zeros on there. Okay, so that's how that works. And all of this stuff is basically handled from what I have as an interpreter. And the thing to keep in mind here is the interpreter just basically says parse the code, which is literally looking through all these line by line, finding all the characters and putting them in a bunch of cells. That's essentially what it does. And then it tells this class called the executor to go actually execute it. And what that does is it just goes into a while loop. And it just keeps going through instructions and instructions and saying, hey, who can support this instruction that I just found? And then you go off and you actually handle it. That's what this mappings handle does. Okay. So to actually show how this works is I wrote this little console app here. Okay. Which, by the way, I just want to mention this real quick. If you look at this main method and you see that I have like strongly typed values coming in, you may go, where in the world is this coming from? There is a project from Microsoft called System Command Line Dragonfruit. And it's an amazingly cool little NuGet package because it allows you to say something like this, where I expect to get a code file and a do trace option from the command line, and it will automatically do all this conversion for me. So kind of a neat little thing. And take a look at it if you want to see, do that in your own console apps as well. But the point is that when I run this, if I'm not passed in a code file, I'm just going to use this 100 digits of pi file. And what does that look like? That's 100 digits. And that will literally print out 100 digits of pi. I'm going to run it just to prove it, okay, in a moment. There's also a couple of examples, and all of these I've just grabbed from other sites and said, well, that's what they're supposed to do. Do they actually do what they're saying they're supposed to do, like 99 bottles of beer, okay? That's what this is supposed to do as well. We'll run that and see what happens there, okay? So let me do this and make sure that that is the startup project. So we're going to tell it to calculate 100 digits of pi. Run it. And what we should see here is 3.1415 and so on. Okay. How it does this, I don't know. I really have no idea what this code is doing. It's one of the things that at some point I want to actually go through this. In fact, one of the things I want to do is eventually add some kind of UI on top of this so that I can actually kind of debug and step through and look at the stack and see how it's actually accomplishing this 100 digits. I really don't know.
Those 3 lines, that little chunk, is Befunge's code to print out 100 digits of pi.
Yep. Yep.
Okay.
Yeah, again, I have no way to tell you how it's actually doing it, but it does it. Let's look at something that's a little bit more less obtuse. If I do the 99 bottles, for example, you can kind of, if you squint, you see the take one down. If you read this in reverse, of beer, no more bottles, you know, because you have to push things on the stack in reverse and stuff like that. So if I come back here and I say, let's make 99 bottles, the one we're going to run, and I say, go ahead and run that. And now what we should see is 80, 70. You can kind of see as it's flying by, it's doing all the numbers. There we go. So there's not a space in between here, but it's doing what it said it would do, is print these all out. Okay. And again, that's just from this piece of code. Okay. So it's, for some reason, I find this programming language just funny as all get out. I don't know why. I think just because it's able to kind of just, you know, go in all different directions in your code, and it looks really awful, and I will definitely agree with that. But it's kind of like in the movie The Matrix, when you start coding this in a little bit, you can get at least a little bit of a sense as to what it's going to be doing. Now again, the 100 digits of pi, good luck. I have no idea, but it's definitely a fun little language, and to create the interpreter was not, like, it's not as complicated as what I think you'll see from compilers for languages that you would use on a day-to-day basis. It's fairly simple, and that's why I'd say this is a really good one to target and to kind of build your own and see what you come up with as well. Okay. All right. So that is fun. I'm just going to come in here and see if there's any. It's just only, oh God, there's a whole bunch of stuff going by with my Python while I was there. And sure, you can fix that space. Yeah, probably. Again, that's code that I copied from somewhere. I didn't actually write it. So if I really dug in, I'm sure I could get it so that it has a space there as well. You know, but I'm just like, I'm just glad that I saw it do more or less what it was supposed to do. Yeah.
You're like, it's alive.
Exactly. Exactly. All right. So that's Befunge. The other language I actually wrote a compiler for, and that's called Whenever. Okay. Again, I didn't create the language, but the language just for, it's hilarious for many reasons. And one of them is the laziness of the language, or just, it's kind of like, hey, I'll do this whenever I want to. And what do I mean by that? Okay, so this is the definition of whenever. It's going to pick a line of code, and you'll see what I mean by lines in a moment. But it picks a line of code at random, and it just says, I'm going to run the code that's in that line. And then that line of code is then removed, and then it picks another line. So that's all that this does. Could you imagine writing an application where you had no guarantee of what order the code is going to be written in? I know that maybe some of you will think that you are working with people in your career that have actually written code like that, or it feels like that. But this does it on purpose. This will purposely execute your code at random. So here's a couple of other things about the language, which is you'll eventually will run every line of code. You just don't know which in order. There are no variables. There's no concept of what a variable is, and there are no data structures. So how could you actually use this language to do something that's meaningful? Get to that in a moment. Here's a very simple hello world and whenever. You can think of this as you create your statements and they all get thrown into your grab bag. Each line of code has to start with a number, does not have to be sequential, they just have to be unique. Okay. And you can see the print there. Print is pretty easy. You'd think that this is going to print out hello, and you're right, it would. What's this 1 pound 2? So that's what you can kind of think of as an update line count command. If you see that in whatever, what you're saying is, if line 1 exists in my grab bag, create 2 new copies of it. What you really end up doing is saying the number of lines value for 1, if it was 1, it's now 3. Okay, so the chances of line 1 being executed would actually go up because there's more of them. If you want to think of it that way. Okay, so that's what that 1 pound 2 thing means. Or if line 3 got executed first, you never see the print hello because it would change its line count to 0, effectively getting rid of it. Okay, so depending on the order of how these things get printed, you might see 1 hello, you might see 2 hellos, or you might see none. It all depends. Okay, there are things that are in whenever to help you out a little bit in terms of getting some sense of order to do things that are meaningful, like defer. Defer says if the condition holds that you will actually defer the execution of the statement and that line stays. You can also use n of x, which will say how many lines exist for a particular line number. Okay. So this will print out 99 bottles of beer on the wall. Okay, and the reason this works is because if I started by picking line 2, it will say defer if line 4 exists, which is what the 4 is saying, and whenever it's saying, does this line exist or not? Or the number of lines of 1 equals the number of lines of 2. Okay. Well, 4 exists when the program starts. So what this does then is it will just simply defer that line 2, put it back in the bag, and then randomly grab another one. So what happens is until line 4 is executed, nothing happens. But once line 4 executes, we suddenly jump all their counts up to 99, and then 4 goes away. So let's say we grab an instance of line 1. 4 doesn't exist anymore. The number of lines of 1 is the same as 2. So we automatically will now print out 99 bottles of beer on the wall. And then one instance of line 1 goes away. So you can start seeing a little bit how this defer helps to giving you some hope of executing things in an order that would make sense, but the performance of the application is going to be random because it might just keep picking lines that get you in a little bit of a spin until it gets down to another pick to actually get you to where you want to go. This will print out Fibonacci.
I have a question about the last one. Like, how would you decrement the number of bottles?
So when you execute a line of code, essentially you decrement that line's instance count by 1. So if after line 4 executes, there's 99 instances of line 1, 2, and 3. If I then executed 1, what that's going to do is then decrement that count for line 1 to 98. Okay. And long story short is if you follow the logic, that's going to defer any other instances of line 1 from running until a 2 and a 3 would run. And then if I pick a 1 after that, then I could do 98 bottles and so on.
So it's not actually like picking that number on line for that 1 pound 98. It's like going by the number of instances that it has.
Yeah, I mean, the way the
Okay.
language is defined, it's saying that you create like, if you go back to this kind of, abstract, if not in abstract, but if you look at it as a guy literally grabbing from a bag, that you like take a copy of the line and then put that piece of paper in the bag. And the to me, the realistic way to implement that in a compiler would be just say for each line, what's the instance count of that line? Just increment that or decrement it or however you need to do that. Okay.
Okay.
So you can, again, you can think of them as their copies of each line, but I personally didn't actually make a whole new line of code for one. I just say its number went up by 98 or whatever it is. Okay. This will actually print out Fibonacci, and hopefully I'll have time to run this as well. The thing you'll see if you run the Fibonacci sequence is one that's really slow. It will start out kind of fast, and then it will start to stutter and get really slow near the end because it has to go through all this crazy again and defer logic just to print out the next number in the sequence. Okay, so it does work, but it's really bizarre to figure out how it's actually doing what it's doing. Again, this one I grabbed. Again, I didn't create the language, and I don't know how somebody actually came up with this, but they did, and I used it as a test to say, does the output work the way I expect it to? Okay, so this one's actually a compiler, again, that I wrote in C#. And I will give credit where credit is due. I basically followed a series of videos by a person named Immo Landworth. He works on the Microsoft .NET team. And for about the past couple of years, off and on, he's been on Twitch doing a stream on building a compiler. And he created a compiler for a language called Minsk. That's just the name he gave his language. And it's not a complicated language. It's fairly simplistic, but he did that on purpose because he wanted to go through how do you start from square one, like literally going through each character in a file and ending up with a literal executable that you could also debug. Okay. And so I went through the series with him, and sometimes I'd watch it, or sometimes I would watch the recording. More often than not, I would need to go back and watch the recording because I was trying to do the same thing for this language, but the constructs are not the same as what he has. It's very, very different. One thing I want to do at some point is actually create a compiler for a language called LOLCODE, which is this crazy funny language that's based on, if you ever remember the meme, I Ken has cheeseburger with cats that make them talk like they're really nonsensical. That's what the language is like. And somebody years ago wrote a compiler for it in C#. I got permission from this person to put it up in a repo on my GitHub site with the intention of modernizing it. What I realized is this person created the compiler from a tool. So the code itself it's almost impossible for me to figure out what's actually going on. So I might just rewrite it from scratch if I can find the time. But that's another funny language to look at. But I did that. I followed his series. So again, Immo Landworth I think his name is Terrajobst on Twitter and also Twitch. I would go through and kind of watch what he's doing and then build the analogs for what I needed. So if you go into the compiler here, and again, won't go through everything, but just kind of give you a little bit of a feel for what I have in here is, you can start all the way from the bottom here, which is if I go in the syntax, there's a lexer, and the lexer lexes all the tokens. If I have this pound, which is really important because that's that update line count token. I need to know that that's there because then I need to make sure that there are numbers on each side of it. So that's a very important token, obviously plus and minus because you can do addition and subtraction among a whole bunch of other things. So the compiler will lex the code. There's also a parser in here as well that's going to go through all the things in the code to create the syntax tree and all the tokens, and there's trivia. If you're in the C# world or the .NET world and you've heard of the compiler API, you may squint at this a little bit and go, this seems somewhat analogous to what Project Roslyn or the compiler API looks like. And you'd be correct, because that's, that's what Emma was influenced by, obviously being at Microsoft, and saying that that's a pretty decent way to structure your code for a compiler. So I have all these things that he was talking about, which again, you would see in something like the compiler API for C#. Okay. And then eventually I will get up to things like in the binding, where I will have something like a bound update line count expression. So this again is representing the expression on the left and the right, which they could be literal expressions, the numbers, or they could actually be statement or expressions that say, I'm going to look at the number of lines doing that n of 1 or n of 3, and I would need to evaluate that to get which line are you actually trying to look at. Okay, so eventually at some point I'm going to actually emit an assembly, and that's in the emitter here, which is, I need to clean this up. It's very large, and there's a lot going on here, and I need to at some point do some refactoring on this. But I use a package called mono.cecil to emit all the IL instructions, and I also emit debug breakpoints as well, because as you're hopefully going to see, if I can pull this off right, is the executables that I create are actually debuggable, and you can debug them in Visual Studio. So that's what this emitter does. Like if I just go to something like emit binary expression, and I go down to something like subtraction, you'll see that I need to emit a call, because all of the numbers in my compiler are represented as big integers. So I need to say I wanted to do the subtract method for 2 big integers, and that's the thing that's going to be emitted into the assembly. Okay. Now to actually build something.
Jason, real quick, when you say emit, is that like to print it out?
When I say emit, what I mean is like create an exe file. You're emitting an executable file to disk, or technically you can do it to memory, but that's what I mean by that.
Okay.
Okay. So what I just did in the terminal in Visual Studio is there's this playground folder that I have, which there is a WS file in there, and I think I have that up in Notepad++ here, right up here. So this is what's in there, and I can just comment and uncomment sections. I actually added comment support as well. And so right now what it's going to do is compile the 99 bottles of beer. Okay, so if I say .NET build, which yes, the WS proj file there, long story short, allows me to actually compile this. It's going to give me an error, but it's actually going to create an executable. Okay, again, this is a little dicey, but it does actually build the exe. Okay, if I go to cd bin debug.net 5.0 and I do a dir, you're going to see that there's a playground.exe there. Okay, and if I say playground.exe and I run it, there's your 100 bottles of beer on the wall. Okay, so that's great, but what happens if I have an error? What happens if I want to debug this? Well, there's a trick you can do with Visual Studio where if I open it and say, I want to create a new project or solution. But where I want to do this from is an executable, not what is typically done in .NET, which is a .sln file. Okay, so I'm going to go playground bin debug and say exe. Okay, now what I'm also going to do is say file, open file here. I'm just going to bring in this WS file as well. Okay, now this is going to allow me to actually debug this executable. The one thing I need to do though is go into its properties, and sorry that this is kind of a small print here, but the debugger type here, what I need to do is change that to managed. Essentially, I need to have it say .NET Core or .NET 5 because that's what I compile it as. Okay, so once I have that in place, now I'm actually going to put a breakpoint on this line of code, because that's the first thing that has to execute before any of the other lines will. So at some point, this is actually going to be hit, hopefully. So I'm going to hit F5 to go into the debugger. Okay. And as you can see, this gets hit. And I can go down the locals here, and I can see like the lines that were actually parsed. Those are represented in this actions thing, which is an execution engine. I actually took what you can think of as the runtime for whenever that represents the lines, their counts, and things like that, and also functions that allow you, if I go back to W# here and show you the runtime, there are in this engine things like that end function, do I defer, do I print, do I do the U, and so on. So I put all that logic in there, and then a compiled whenever program just uses that engine to kind of manage some of the state things. But as you can see here, we hit line 4, and now I got to put breakpoints on all these because now I don't know which one it's going to hit. Okay. But now if they hit F5, you'll notice that the next line it picked was 2. Well, it's not going to do anything with 2, right? Because it can't run that yet. We need 1 to run. We hit 3, we hit 3 again. Now we hit 1. So when I hit F5, when I go back to the console window, we should see 99 bottles of beer on the wall. Okay. So this compiler it's fun because not only does it create an executable, but I can actually debug it if I want to. And it has all the support in Visual Studio for me to go through and debug and see what's going on with the program. So that was kind of fun to do. Yeah.
Jason?
Yeah.
What would be the use case for such a language?
None. The use case is kind of what I was saying at the beginning, but I'm going to kind of answer that as well, hopefully at the end here, which is, would you ever do this on your day-to-day job, like actually using these esoteric programming languages? Dear God, I hope not. You know, that would be just awful.
I was hoping you'd say something like unit testing or something like that.
Unit testing a language like that?
No, unit testing something where you need something happening in a random order.
Oh, I would just create a random thing that would create me random numbers.
Fair enough.
But just to finish out here real quick, the fun part about these languages to me is the actual experience of building these interpreters and compilers. And yeah, somebody could say that's wasting time. Like, again, my day job is a developer advocate. I don't write compilers for a living, but I find these things utterly fascinating. These are things that all of us as developers are either using compilers and interpreters all the time. Okay, and so for me, it's been very educational. Even if I'm not going to be creating like a DSL or a language within the company that I work for, you know, it still brings a lot of insight for me. And so to me, it's not wasting time. The time that you enjoy wasting is not wasted time. I love this quote. Okay, if you love doing something, just do it, you know, and you're going to get value out of doing that. And for me, investigating these languages and trying to actually make stuff to make them work is not wasted time to me. It's things that have been very educational and have been insightful for me. So that's what I hope to, you know, kind of inspire people here as well as, don't start using Befunge in your day-to-day programs, but look at some of these languages that are on that site that I mentioned before, and maybe just as a side project, you know, start saying, hey, how would I actually make these things work? Maybe you want to get into Twitch and start doing streaming. Maybe start putting a stream together that says, hey, I'm going to start building a little interpreter for this language. I have no idea what I'm doing, but this will be fun and I'll give it a whirl. And if I find out about it, I'll watch it and see what you do. So anyway, thank you all for attending. I hope this has been fun. And if you have any questions, you know, got a little bit of time, but again, otherwise you can just email me, jason.r.bock@outlook.com. So again, thank you all for attending.